And thanks everyone for showing up for the webinar. Today we're going to be talking about leveraging search and the capabilities of Fusion and Solr and Lucene as part of a broader data science toolkit. And in many ways this talk is kind of lessons I've learned over the years, digging in on data, trying to figure out what's going on in that data, how it can be made useful for clients, customers, and even ourselves. And so what I'm going to do is lay out kind of the foundation around how I think and how we as a company think Fusion can help data scientists, and then also look at some real-life examples using Twitter as a live data stream coming in, and do some interesting examples of analytics on that data, show some visualizations that you can do very quickly out of the box, leveraging the capabilities in Fusion. So with that in mind, what we're going to do is actually get started by digging in and start some of this process going. And as you can see here on the slide, I've got a GitHub project or repository set up that contains all of these examples that you're going to see running here. I'm going to use a mixture of the Fusion UI as a way of pointing and clicking our way through this data, but I'm also going to drop down at times to the API level and show you what the actual REST API calls look like when we go and do this data processing. Rest assured, everything that I do in the UI will have a complementary or similar REST API call underneath the hood that's checked into this GitHub repository, so you can go and download it and try it yourself. Okay, so let me just switch over to my web browser and we'll get started with this, as well as looking at Postman. If you're not familiar with Postman, it's a great little client that plugs into Chrome and allows you to very quickly set up and make calls, kind of like curl, but with a little bit nicer interface. So I'm going to do a couple of things here just real quickly to set up things. The first thing I'm going to do is create a collection to hold my content. I will show you what this looks like in the UI here in 1 second. I'm going to kick that off, but just for my own purposes to make sure that I don't do something stupid as I'm typing, I've got all this stuff essentially scripted. I'm going to create a collection, and then I'm going to turn on Fusion's signals capability. If you're not familiar with signals in Fusion, I encourage you to go and look at some previous webinars that I've done that have highlighted how we use signals to improve relevance and all of that. And as you see here, when I get into our aggregations and some of the statistics we can run, I will be relying on the signals capability to do those things. Next, I'm going to go and create a Twitter data source, which takes in live stream of tweets and then maps them into the Solr index underneath the hood. Buyer beware right here. I'm going to be doing this off of live Twitter, so I apologize in advance for the idiots that are on the internet who sometimes post things that aren't safe for work. But rest assured, it's just part of Twitter coming in. And in fact, if you look at previous examples I've done with Twitter during webinars, I've shown you how you can use Fusion's pipelines to automatically filter that stuff out. So I've gone ahead and I've created the Twitter data stream. Next up, I'm actually going to start that indexing process, and then I'm going to do a couple of other little housekeeping things, which I will come back to later around pipelines and display of that data. So I'll come back and visit those. But just to see what this looks like, I'm going to log in now into Fusion, and I will show you what I've done. We've got obviously our Fusion Launchpad here. I'm going to go into the admin. You can see here I've got a Twitter collection. That's the collection I just set up there. You can see already it's got almost 1,000 documents in it in just the, 2 minutes that it took me to get that set up. If I pop under the data sources here, you can see that, yes, indeed, this Twitter data source is up and running. If we go in and look at it a little bit more closely, you can see some of the values that go into that in terms of making sure we're leveraging the Twitter APIs and all of those things. The other things I did was set up 2 query pipelines, one for dealing with the Twitter data itself and one for dealing with the signals and aggregations that we're going to be looking at here in just a minute. Showcasing the Twitter default pipelines, you can see I've just got a couple of simple things set up around faceting on certain attributes of the data. So let's just go confirm that this is all working by popping into our search UI. I'm just going to switch tabs here and then go back out to search. As you can see there, I'm going to choose the Twitter collection, and you can see right off the bat I've now got search results flowing in, and I've got examples of those facets going down the side. So one of the things first off that you see in thinking about data science and my experience with data science is I need to go and understand what's happening in the data. What does this stuff look like? What are the attributes of this data? Does it have timestamps? Does it have spatial information? Does it have free text? Does it have numeric information? What can I go and do with that? What ideas might that be just simply by looking at a set of examples around this data? And I think you'll find that at its heart, search is really good for this when it comes to thinking about what are the data scientist tools that one wants to use. So that's kind of a quick tour of setting up and getting data in. As you can see, it's pretty easy. One of the last things we can do here is also just take a look. I've set up a little dashboard around this data, and so we can take a look at that. We'll come back and revisit this here a little bit later when we think about some of the, as we get into some of the facets and things that are going on in this data set. So with that, I'm going to pop back over to the presentation. We're going to talk a little bit about kind of the foundations around Fusion and why we built Fusion and how I think that relates to data science. And then we'll get into some very specific use cases that we commonly see around how people leverage search and how they leverage Fusion to do data science, and then how that can relate to other applications they are building. So first and foremost, when I think about Fusion, I think about a few key foundational items that I think really lay the groundwork or lay the framework for building out next generation data science or next generation applications. First and foremost, we build on top of Lucene and Solr. If you're not familiar with Lucene and Solr, I would encourage you to just go to lucidworks.com, and we have a ton of information up there around leveraging Lucene and Solr in a variety of different situations. At the end of the day, Lucene is a core Java library for doing search and search-related activities. And then Solr takes and adds a whole bunch of things that would be mostly require programming in Lucene. They're mostly convention or configuration in Solr. It also adds things like REST APIs. It adds distribution capabilities, scaling capabilities, faceting and slicing and dicing. And we'll get into how those features of Lucene and Solr enable more things in data science in a minute here. Second really key foundation is this notion of signals that I talked about earlier. If you've been paying any attention at all to the likes of Google and Facebook and Amazon, et cetera, you know that one of the things that really powers content on those applications, those sites, is the fact that they take in feedback from users and other systems all the time in an effort to then go and improve their content going forward. So in our lingo, if you will, that's what we call a signal. A signal is a click, it's a share, it's a rating. It's the fact that people on this call are attending this webinar. It's the fact that I've emailed with somebody. It's the fact that they've shared a document, et cetera. All of those little pieces of information by themselves aren't actually all that interesting, but when you start to combine them together, then you can start to feed that back into your data, overlay it with your data, and get much deeper insight into what's going on with that content, much deeper insight into what's going on with your users, and thus make for an overall better application. So that's kind of pillar number 2. Next up, we think a lot about data ingestion and analysis and visualization, all with, kind of feeding off of that signal capture capability. So I want to make it really easy to get data into my system, and then I want to make it really easy to do analysis, ranging from that ad hoc search that we talked about all the way through to things like discovery and faceting and did you mean and recommendations and basically anything where we can leverage the power of the user, that hive mind, that collective intelligence to make our system better. And then the last 2 things really are kind of just, bread and butter, I think, for any real data platform these days, is you want to make sure this stuff scales, and you want to make sure it plays really nicely in a big data environment like Hadoop and the Hadoop ecosystem. And you'll see later on when I talk about Spark that we leverage big data tools in a lot of really interesting ways, and a lot of ways that make your use of them a lot simpler in the long term. So what does all of this stuff look like? Here's a, kind of a high-level diagram of Fusion underneath the hood. You can see on the right-hand side here a couple of key open source projects are really what power Fusion. First and foremost, like I said, we're built off on top of Solr and Lucene. Obviously, we're using Solr and Lucene for the core content that we want to index and make searchable, but we actually leverage Solr for a lot of different things as well. Things like storing our machine learning models, things like storing the state of the system that we need to capture, things like storing user information, so on and so forth. We leverage Zookeeper, obviously, for its rock-solid stability under load and in a distributed environment, its ability to deal with failures in a large-scale distributed system. And then last but not least, I referred to Spark earlier. I'll get into a lot more details on how we leverage Spark here in a minute. But we ship a standalone integrated Spark system that works natively with Solr and with Fusion and thus allows you to run Spark jobs on top of your search data. And I think that's, as you're going to see here in a minute, that's really powerful when it comes to doing some of these data science things that one wants to do. The kind of middle tier here to the left of Solr, this is really all about Fusion services. The large majority of our services are stateless. They can be scaled up in much the same way that Solr is. They rely on Zookeeper for things like leader election and load balancing and distribution. You can see we ship with a number of services out of the box. And then last but not least, at the left-hand side, we provide REST APIs out to everybody. We do proxying and load balancing and take care of all requests coming in and routing them accordingly to who's available. Last but not least is, we want to live in the enterprise. We know that we've got to secure all of this stuff, and so we've very deeply integrated security of not only the system but of the data as well throughout all of this so that you can integrate with your LDAP, with your Kerberos, with whatever other security systems you have in place, and thus take advantage of all of the Fusion capabilities, or at least allow the right people to take advantage of the right things at the right time. So that's a real quick and dirty high-level view of Fusion, kind of the founding principles of it, as well as some of the architecture. So then let's segue in and talk about data science. First and foremost, I just want to say, hey, I'm an engineer at heart. I started my career as a software engineer. I've been a computer programmer all of my career. I am not a quote-unquote officially titled data scientist. That being said, I read a lot of the materials that data scientists put out. We work with a lot of different data scientists at Lucidworks. And really what as I said earlier, I'm doing here is collecting a number of observations that I've had about data science and about how data scientists can leverage search and Fusion in their environment. But if you want to ask me really hardcore statistical questions, I'm probably not the guy for that. So with that in mind, let's go forward and kind of dig in on some of these use cases. And I think there's a number of them. I've listed a bunch of them here, and then we're going to drill in on a few specific ones here in the rest of this webinar and throw some demos up around these. But as I see it, there's kind of some real quick highlights here. First and foremost, data exploration and visualization. I think we would all agree, if you think about the modern age around the internet and big data and all of that, the most ubiquitous interface that any of us have into data is a search box. And so when you start with a search box and then you add faceting and you add aggregations and you add visualizations on top of that data, you are giving your users an incredible amount of access to data. In many ways, you're democratizing that data for your company and for your system. Whereas in the past, all that data stuff actually had to be done by hardcore statisticians or hardcore data analysts. Now you can actually let your users ask the questions, and then you maybe just need to guide them with some specific capabilities or specific pipelines in Fusion that do some of the lower level dirty work for them. Number two, really, one of the things that kind of goes with data exploration is you've got to get data in very quickly And then you need to be able to do things like feature selection and data reduction. I'll talk about some of the ways that Lucene and Solr and Fusion enable this here in a minute. Next up, REST APIs. Everybody's doing REST APIs, JSON. That is the lingua franca of Fusion. So as you'll see with our Postman examples here, it's all just making JSON REST calls and getting back the appropriate responses. This next one, the quick and dirty, this is one of the things that I think is really interesting when you think about how search engines work, right? And that is, you've essentially got this vector space representation of your content and of your users. And if you start to think about other algorithms outside of search like classification and clustering, well, it turns out there's a number of easy-to-get-going examples around classification and clustering that the math is more or less the same as what a search engine is doing, right? That is, it's exploring a vector space model. And so you can build out very quickly things like k-nearest neighbor classification or k-nearest neighbor clustering examples and get a sense right off the bat of whether this data is going to be something that is amenable to doing classification or clustering. And then, of course, you can then go and dig in on it at a much deeper level. And in fact, if you go get my book, Taming Text, we have examples in there of using Solr to do things like classification and clustering. It's all open source code. Just Google Taming Text, GitHub, and you'll find all of the code there. The last three things I think are really interesting in terms of digging in at a much deeper level around data science. And of course, as a data scientist, you're using tools like R and MATLAB and the like to really dig in on that data. And I think one of the things that we wanted to make sure we could do is bring the power of math and stats in a framework that allows people to very easily express their models and build their systems and do the analysis of the data. And so we wanted to, one, have a batteries included way of looking at this data. So we're shipping with a number of capabilities out of the box, like NLP tools for doing part of speech and sentence detection and named entity, as well as functions around math and stats. But then we also wanted to make it easy for people to plug in their own. And I'll show you some examples of these here as we go. And then last but not least, we wanted all of this to be scalable because, it's one thing to start off with very small models, but then you quickly need to be able to grow and scale with your data so you can address all of that stuff that's coming in from your users. So those are some of the kind of founding data science use cases. At the end of the day, the big caveat here is when I think about data science, I think about us, that person having a lot of different tools in their toolbox. And so one of the things, I would say is that Fusion is not the be-all, end-all tool for every last data science use case, but as you can see here, there are a number of really compelling data science use cases that I do think we bring something unique to the table that other systems like, just plain old writing MapReduce or SQL or Hive can't do because of the inherent nature of search and the way those algorithms work. And then the way that we've integrated them in with Spark and integrated in a number of other capabilities. So with that, starting to think a little bit more, peeling back the layers on, well, what is Fusion? Well, Fusion ships with Solr and Lucene and Spark and all of these things. And in many ways, Fusion is building on top of those. So when I think about what can I bring to the table in terms of data science and Fusion, I really start at the Lucene level because I think there's a lot of really interesting capabilities down there. First and foremost, obviously, is a really fast and efficient core search algorithm that is essentially doing vector space or probabilistic modeling of your content that's coming in. And in fact, that core ranking algorithm is very pluggable. And so you can plug in different scoring models, you can plug in different storage models, and all of these different things to mash up your data. Lucene is very efficient and effective at storing and managing lots of different data types ranging from text to spatial to enumerated types to keywords to really whatever you want it to be at the end of the day. Lucene is very flexible about it because at the end of the day, it's essentially this large sparse matrix representation of the content that you want to store. And it's been really good at ranking that content and providing you back a list of what it thinks is important according to some ranking algorithm. Next up, Solr on top of it, as I mentioned earlier, really brings to the table all of the things that you had to program in Lucene are now just convention or configuration. And so scaling Lucene is super easy, but more importantly, you can add a bunch of other things on top of it, like Solr has pretty deeply integrated stats engine so that you can do things like mean and min-max, and we just added hyperlog log, and we just added a few other stats in there, as well as a number of function queries for calculating your own quantities as you see fit. And then things like, it's got a number of different faceting algorithms which will allow you to slice and dice and explore that data. And then perhaps, a lot of people don't know, but Solr actually ships with the UEMA integration for dealing with like NLP data structures. It ships with some clustering capabilities, et cetera, et cetera. And so all of these things add up to you being able to get in and deal with your data in a lot of different ways. And then when I think about Fusion on top of Solr, it's all about how do we complement and extend Solr. So things like pipelines and connectors and dashboards, Spark, et cetera. You can see how all of these add up to be a much more interesting story than any one of them on their own. So with that, rather than talking about it, let's actually get in and look at this data a little bit more here. I'm going to switch back to Chrome and just let's go in and look at this data and some of the things that we've set up in terms of the faceting and the basic stats and capabilities on top of it. If I can find my window here, just give me 1 second. There it is. So as I said before, one of the things we did is we've got all these pipelines built in. Just digging in on those pipelines a little bit more, you can see that we ship with a number of stages out of the box. So if you think about a pipeline, essentially what's happening is your data either at indexing time or the request at query time is going through a series of stages that are going to alter and or append or delete values from that request. And so as you can see here, we ship with a number of those out of the box. So for instance, if you wanted to add recommendations based off of click feedback from users, that's as easy as just clicking a box and filling out a few parameters here, and voila, assuming you've got signals being captured, you've now got a nice exponentially decaying click-based recommendation model that works quite well for most people in most situations. In my particular case here, I've set up a few values here just to allow me to go and explore this data. I've set up a few facet fields. One is on the hashtags that Twitter provides, another is on the mentions of user screen names, and then another on retweets. So that's kind of field faceting 101 there if you're not familiar with Solr. I've also passed in, and you can pass in arbitrary Solr query parameters. In this particular case, I'm also doing some range faceting on things like the retweet count, as well as various other things like pivot facets. Pivot facets are an actually really interesting way of thinking about your data, kind of like an Excel spreadsheet pivot table. They allow you to go between, say, if this language facet were clicked, what would the retweet counts look like? So rather than talk about that, let's actually go look at what this looks like live in the system. I'm just going to do this search again here. As you can see, I've already got 50,000 documents that have been indexed in just a matter of time that we've been talking here. As I mentioned down the side here, I've got my facets. So right off the bat, you can see that, there's a number of hashtags coming in, and people are talking about the FIFA scandal. People are talking they want Selena for the Much Music Video Awards, and there's a few other ones in here. And you can see there's a whole bunch of mentions of usernames, stuff like that. And some of these are retweets, some of them are not, and you could see some of the distribution across the languages. So right off the bat, I'm starting to get a sense of what this content is. It's actually interesting. One of the things in me setting up this demo that I noticed is that every time when I would start up and run this demo early in the morning, all of my content would be either Chinese or Japanese. And in fact, obviously that kind of makes sense. If you think about it, I'm in the Eastern time zone. And, people in Japan and China, et cetera, are tweeting after work in the evening when they're out and about doing things and so on and so forth. Scrolling down, here's some examples of the pivot faceting. You can see we've built in the ability to display these right off the bat. So you can see, for instance, when I pivot between language and whether a given tweet is retweeted or not, you could see of the 23,000 odd English files, English tweets, about 14,000 of them are not retweets, and almost 9,000 are retweets. And the really cool thing is you can actually do this on the fly. These are all just requests to Solr. And by using this in a pipelines, you're able to then take advantage of the ability to hot deploy them, to change them around, swap in and out, without going and repackaging up and re-releasing your core software. And so this brings a lot more capabilities to your users in terms of how they ingest and deal with requests for their data. Last but not least, I've got some facets there around screen names and all of that kind of stuff. And of course, I can do searches in here just like you would expect, and I can look at the fields in more details. If we come back to our dashboards example, I'm just going to pop back out here into Fusion itself and show you how I got here. So we come in here, Fusion actually ships with these dashboards built in. They're all, by the way, secured and ready to run with Fusion. In fact, what you're seeing here is the default dashboard, which is Fusion consumes all of its own logs as well. But that's all well and good. What I'm interested in is the dashboard that I created for examining this Twitter data. So I'm just going to go in and load that up. And you can see now I've got, some of those facets that I had in the built-in search UI, I now have visualizations for. And of course, if you're familiar with Kibana, you can go and set up your own panels here and do your own searches and essentially slice and dice and visualize this data as you see fit. So far, so good. I think you would agree with me. There's a lot of great ways to get content in and then go and explore that data. And I've only touched the tip of the iceberg, if you will, here in terms of the data exploration. If you really want to, you can also drop down to the very low level with Solr and look at the raw content and make any Solr query that you want. And in fact, I've done that here in my if I can just find my window here. Again, I've set up a few Postman examples of calling Solr and just getting back Solr results. But in this particular case, we're not just calling Solr, we're actually calling a Fusion query pipeline and getting back results that go through that data. And you can see I can print those. And so at a very low level, rest assured, we are returning JSON that you can then go and operate on. So if you want, go and explore more of those in the GitHub project that I mentioned earlier, and I'll be sure to share that with people as we go here as well. So that's kind of getting started in data exploration. I hopefully kind of piqued your interest in the ways that you can think about getting all of this mixed up, mashed up data in, and then starting to do interesting things with it. And I think some of those interesting things, when I think about data science, kind of fall under kind of the ugly side of it, or the less interesting side of data science. I think, most of us, when we think about data scientists or we think about building machine learning models and all that, we fancy that we're going to spend all of our time on these really interesting algorithms where we're building this just beautiful classification model. And I think anybody who's done this in the real world realizes that they're going to spend a whole lot of time on the garbage in, garbage out problem. That is, how do I get content in that's valuable? How do I identify the key features that are interesting? How do I make sense of the volumes of data? How do I reduce the noise? How do I get more signal and all that? And when I think about Fusion and Lucene and Solr, I think, we've got a lot of capabilities in there that help the data scientist. Even if you were never to use the rest of the system, these would still help you a lot in terms of getting data in and getting it into a format that is usable by you in a very quick and easy to use manner. So first off, I mentioned, Fusion's got a ton of connectors. I think all told now, since we added Logstash in as a connector, we've got 60 plus connectors out of the box that are as simply as clicking a button and providing a few parameters around setup. So connectors ranging from web crawlers to syslog listeners to file crawlers to SharePoint to Twitter, so on and so forth. And then last but not least, you can always just use the REST APIs and upload files. You can push data in using JSON or other formats, so on and so forth. Digging in a little bit deeper, this is where I think, Lucene, especially when it comes to dealing with text or text-like data, is really good around feature selection. Feature selection being this problem of identifying what in the content is actually going to be interesting. Do we care about timestamps? Do we care about the body text? Do we care about the usernames? Do we care about where this person is located? How can we separate out content in, for instance, a log messages? Separate out a log message based off of, perhaps its logging level or the actual log message or the timestamp. So Lucene and Solr provide a lot of capabilities underneath the hood there. We overlay our pipeline capabilities to extend those even more to do things like named entity extraction, so on and so forth. Then once we have those, I think you have this really incredible capability to go in and calculate weights and build up, essentially vector or probabilistic models on top of that data, leveraging Lucene's kind of built-in capabilities for those things. You can also do what's called attaching a payload to any particular content. So for instance, if you wanted to tag all text as it's coming in with part of speech labels, you can very easily do that by indexing the core text as is and then attaching a part of speech payload onto that content, such that if you then want to go build a question answering system, for instance, or if you want to search and only find the usages of certain words that are verbs, then you can do that kind of thing. Last but not least, under feature selection, you have very low level and very fast access to the actual term vectors that are being created. So if you want vector representation of your content, you can get that. And you also have access to the actual term dictionary and the posting list, the places where all of these terms occur in your content. So if you want to get beyond bag of words analysis with your text, you can do that leveraging these kinds of systems. Last but not least, I think any good data scientist will tell you they do spend a fair amount of time trying to figure out how do I actually reduce the size of data that I have? And I guess you could say this is also part of feature selection, but I do think there's some interesting things you can do here, leveraging Solr and Lucene's built-in ability to apply filters. So you can filter by time, you can filter by tags, you can filter by whatever attribute you really want. The analyzers themselves, the language analysis tools, the way we can slice and dice data in kind of a mini pipeline, if you will, before it even gets indexed, so you can remove things like stop words and other data that you don't care about. Maybe you don't care about numerical data. Maybe you don't care about text data, whatever. You can drop that out of your content before it even before it even gets into Lucene or Solr to begin with. And then last but not least, if you actually go to Lucidworks GitHub page, we provide a number of data quality tools out of the box. These are designed to operate on your Lucene and Solr indexes and work with Fusion as well to basically identify places in your data where you have bad content. So for instance, it very quickly can find outliers based off of things like character sets or length of fields, or where you have empty fields, where, in other words, you're not getting the proper data value set. And so these really can, all of these kind of add up to helping you better understand your content. So that's kind of the nitty-gritty, I think, of one of the things where I think all of us as application engineers or data scientists spend a lot of our time in is how do I make this data usable? The more interesting side then I think is how do we get in and actually leverage some of the aggregations and math capability that are built into both Solr and built into on top of Fusion. And so one of the things I like to think about and talk about with people who are maybe new to search, especially if they're data scientists or statisticians and haven't used or understood how core search works, I think one of the most interesting things is, first and foremost, search is really good at ranking things. And the way it does that ranking is typically by doing a vector times a matrix calculation. So if you think about a lot of these data scientist problems relate down to being, vector times matrix or matrix times matrix, search is essentially a subset of one of those. And so when you start to think about search as that kind of problem, your mind all of a sudden opens up to other types of problems that can then be solved. So things like building a recommendation engine is a very natural fit on top of a search engine. And in fact, I'm not the one to invent that. There's been a number of people out there who have done that, places like Career Builder or Apple and a number of music stores, et cetera, all in LinkedIn, all leverage search under the core, under the hood for doing recommendations. And then, so that's kind of one of the core things built in across all of this framework. One of the things that we then added on top of it with Fusion is this notion of aggregation. And what we wanted to do is make it really easy to enable this advanced computation on both your core content as well as the signals. So in fact, any piece of data that is in a Solr index anywhere in Fusion is a candidate for doing aggregations on. So in fact, here you'll see in a minute when I get into the demo, I'm going to take this Twitter data and we're going to start to ask some interesting questions of it just using the aggregation capability built into Fusion. In fact, this aggregation capability is what we did at first blush to work with Fusion signals. This is the way we build our recommendations. This is the way we think about our low-level system metrics, all of that kind of stuff. We're essentially doing these aggregations and roll-ups on core content in Solr. And so we wanted to start by first making it easy to try out by leveraging Solr. We put all this data in Solr. You can query it. You can look at it. You can examine it. And then we wanted to also ship with a number of pre-built named aggregations, if you will, out of the box to cover common scenarios, so things like the recommendations that I mentioned earlier, so on and so forth. And then last but not least, we wanted to make sure that you could then go and build out your more complex functions. And I'll show you an example of those here in a minute after I get and talk a little bit about Spark. So if you're not familiar with Spark, this is an Apache project that started at, I believe, the University of California, Berkeley. It was essentially is marketed and lives up to the promise of being the next generation of Hadoop's MapReduce algorithm. And so it's much more efficient, especially at iterative style computations. It's much smarter about memory usage than MapReduce is. It's much smarter about when and how jobs are started, stopped. And so at the end of the day, you get this incredible speed up over MapReduce such that, if you look at the Hadoop space, the large majority of people have abandoned Hadoop MapReduce or are on the path to abandoning Hadoop MapReduce and replacing it with Spark jobs. So we saw this trend, and we wanted to make Spark something native to Fusion and take advantage of some of the work that we've already done to integrate Spark with Solr, such that you can, for instance, use Solr as an RDD in Spark. And this is essentially using Solr as a data storage format in Spark, and thus Spark can then operate over Solr and all of the data types in Solr as it sees fit. And so what we've done is integrated that in very deeply with Fusion. And this allows us to then take advantage of all the great work that's being done on top of Spark in machine learning projects like Mahout or Deep Learning for J or MLlib, as well as take advantage of graph algorithm, graph capabilities like GraphX. So now all of those things just run natively on top of Spark in Fusion and thus access all of the data that's available in Solr. And it's really as easy as what you see down here at the bottom. There's no big setups to do. We've got it all ready to go. You just literally download Fusion, CD into the main directory, change directory into the main Fusion home, do bin Spark start on each of the nodes that you want to be Spark nodes, and voila, you now have a full Spark cluster running. And then when you get to running an aggregation job here, when I show you, which I'll show you in a minute in Postman, it's literally as simple as appending a flag that says, I want to leverage Spark to do these aggregations instead of the core Solr aggregation. And so you might ask, well, why do we do that? Well, Solr is great and all. It can scale to a lot of, very large sizes. But when it comes to aggregations, Solr's first and foremost use case is ranking and returning the top 10 results, top 50 results. It can do deeper results if need be, and I'll show you, we'll be doing that here in a minute. But when it comes to truly large scale, Solr still just can't keep up with what Spark is able to do in terms of large-scale batch computation across, large volumes of data. And so that's why we wanted to ship it and provide Spark out of the box for our users. So with that, you've seen a hint of some of the aggregations. Let's actually go in and run a few of these. I'm going to switch once again to my browser and Postman. And this time we're going to look at some of these API calls in a little bit more depth and talk about what these aggregations look like and actually run some of them and see some of the results. Switching back. So what I've done in my Postman here is I've got a whole bunch of aggregations. I'm not going to cover all of them here. And oh, by the way, if this is not showing up real well in your browser, I'm told by Aaliyah that if you put your screen into full screen mode, this shows up a lot better. But rest assured, you can go and download these later, or you can refer back to the recording later on. So one of the first things I'm just going to do is I'm just going to get a list of the existing aggregations in the system. You can see the endpoint that I'm hitting here up at the top, and then you see a list of all of the different aggregations. Some of these, like hourly metrics and daily metrics, those are internal Fusion aggregations that we run to do roll-ups on our system metrics, like what's happening with garbage collection and all of that stuff. And then some of these other ones, like top words and cardinality and all of that, are what I'm going to talk about here today. So what I've done is I've listed out those aggregations. I can always also go and look for the specific definition of any one of these just by simply putting the name on the end and issuing a GET. And now you can see, for instance, this really simple word count problem aggregation here is really made up of a couple of different things. First, it's the core part of these aggregations is this aggregate section, which defines what are we going to do on the source data that we have in the system. So in this particular case, I'm saying that I want to split on this value called tweet split, and then I want to count that data. Looking at some specifics here, one of the first ones we can do is actually look at counting how many unique languages are represented in this data set. So we're going to calculate the cardinality. In Fusion, we're using the T-Digest program by Ted Dunning. This calculates a hyperlog log. So it's a really fast way of estimating cardinality without necessarily being 100% accurate. So I've set that up. I can actually send this in. You'll see I get back the raw results here, 204, no content, which we're all good. I can then go off and run this aggregation. And this will take a little bit of time to iterate over the data, but not more than a few seconds. While that's running, let's look at a couple of other things. So for instance, here's another aggregation that's all about what are the top words. So one of the functions built into Fusion's aggregation library is called TopK. That is, return me the top 10, the top 20 results for this particular value. So in this particular case, what's happening is I'm taking in the raw tweet data. As you can see there, it's called tweet underscore T or underscore text. I'm then leveraging Fusion's built-in split capability. In this particular case, I'm just doing something really simple like splitting on white space. You can see I can pass in a regular expression here. And then I'm calculating this top K. So we can go and run this one as well. And then similarly, we can do things like top K for hashtags. So in this particular case, I'm looking at those tags, and I'm doing top K on that. So let me just kick off a few more of these, and then we'll go and look at the results. So for instance, here's another interesting one. We're actually going to be looking at the top words by author, or the top K tags by author. So this is another capability that's built in. You can actually group on any of the values in your content. So in this particular case, I'm grouping by author first, and then I'm going to calculate the top K. So at the end of the day, this ends up being what are the top words used by each author, right? And so you can see the definition of this is very simple and easy to do. And so we can go off and we can run those. I can also do top hashtags per author. We can send that in. We can run those, and so on down the chain here. Another really interesting one, and I've just set this up as a simple example of how you can actually provide your own code to go and analyze this content. So one of the things the aggregation framework has built in is a callback mechanism where you can provide JavaScript or other means to then go and analyze that data and output results. So in this particular example, I'm taking in, again, that same Twitter data, the core tweet. I'm splitting it on white space, and then I'm actually feeding it to a JavaScript function and just calculating the size. So now what I've got is a count of all of the words for each tweet. I can then go and calculate what is the average word count across all of those tweets, and we can kick that off and run and so on. I can also do this by adding in a grouping clause, so it's that same average words by tweet or average words by author, but this time, it's average words in the tweet, but this time by author as well. And so I can go off and run that. And if you see, we can also then, while this stuff is running, we can get a listing of all the jobs. And you can see already that all of these have finished except for the last one. So we'll give that here a minute. I'm going to just send a message to Solr to make sure that data is available. And then we're actually going to go back to our Fusion search page. And I'm going to, instead of searching the Twitter collection, I'm going to search those aggregation collections. And you can see we now have 110,000 aggregates that have been calculated. The large majority of those, as you can see by the facets here on the left-hand side, where I've faceted by the aggregation job, are that one that was average word count by author. So for instance, you can see this particular Twitter user, Ahmed Bilir, he went and tweeted however many word count is in there. I think I've got a little bug in the system right now, but you can see the average word count down the side here. So for instance, 14,000 of these authors have used somewhere between 3 and 6 words on average. And so I can sit and slice and dice this aggregate information as well. And I think that's one of the really powerful things that can happen as well. All of that signal data that's often locked up in your logs or locked up in marketing is now very easily accessible to you as the data scientist or you as the application engineer. And you can, in fact, interact with it in much the same way you interact with your core data, i.e. you can search it, you can facet it, you can aggregate it, so on and so forth. With that, I'm going to just switch back again. Like I said, all of these examples are available on this GitHub page here. As you can see in the window, there's some directions on how to get started with it, how to run it, what the prerequisites are. I would encourage you to go and check it out, as well as notice that it's part of a broader collection of Fusion examples where we as a company are posting common scenarios or solutions to common problems, et cetera, that one can do with Fusion. There's already a few other projects and examples up there that you may want to check out as well. With that, in the interest of time, I'm just going to switch back to my slideshow, and then we'll have a few minutes for questions here in a couple of minutes. One of the other things that comes with Fusion, if you think about those aggregations, they then become very powerful in terms of powering higher level capabilities. And one of the ways we leverage those aggregations is to build out a recommendation system on top of this. And so it's very easy to set up. And in fact, if you've seen some of my previous webinars on Fusion with signals, et cetera, you can very quickly build up collaborative filtering style recommendations such that you can answer questions like people who bought this also bought that. You can do things like calculate people who searched for this, search for that. You can figure out what are your top spelling corrections, what are your top highlighting snippets. All of those things as signals can then be fed into a recommendation engine that you can then feed back to your users. You can also do now very powerful session analysis using what we call our event miner capability. This is all documented in our docs, which I'll provide links to here in a minute. At the end of the day, the really cool thing that you have in front of you with Fusion is this ability to build a multimodal recommendation system. combining a number of different key things that I think make for a much better experience for your users. First and foremost, the core search provides the ability to match on content, i.e., given this query, what content should I recommend? But then with the aggregation capabilities, I can overlay on top of it collaborative filtering style recommendations, i.e., people who clicked on this also clicked on this, people who bought this bought that. And then I haven't really talked about it much here today, but Lucina's Solr has a really killer spatial capability built into it, such that you can now overlay location information about both the user and the content into your system. And then last but not least, you can provide historical or contextual information that helps you really personalize this data. That is things like, what has this user queried for in the past? Does this person like sports, or do they like entertainment? Can you boost or weight content based off of that kind of insight about your user, such that at the end of the day you have a much better chance of matching what they're looking for based off of all of these factors, as opposed to just leveraging core search and doing keyword matching or content matching. So with that, a quick look at some of the things that are coming up in Fusion. Rest assured, we're working really hard to get our next version out. We just, in fact, released Fusion 1.4, and that's what I've been built this demo on, but we're hard at work at new things. So, for instance, with Spark, you'll have the ability to run non-Lucid Spark jobs. You'll be able to submit any Spark job that you want. You'll be able to integrate with third-party Spark instances. So, for instance, we're partners with Hortonworks and MapR and Pivotal and others, and you'll be able to leverage their Spark deployments as well. We're also busy working on extending the RDD capabilities for Solr and the integration with Spark, also working to make sure it's as performant as possible, such that that integration is very easy and fast to use. Last couple of things were, I showed you a lot of these aggregations via the Postman REST API, and I think that's great for programmers and data scientists. But there's also a whole host of users who would want to set up aggregations or leverage, or at least look at and try to understand those. So we're working on a UI for that. It'll be built into the Fusion UI. And then last but not least, we've got a couple of other things that essentially amount to more math and more capabilities for the data scientist in terms of how they're going to access the data, the way they can create relationships between their data, so on and so forth. So with that, I'm going to take a pause, and I believe what we're going to do is Aaliyah and somebody else at Lucid have primed up some questions for me, so happy to take, it looks like we've got 5-10 minutes left for questions. In the meantime, feel free to check out any of the links on the page here for more information on what I talked about, and of course, feel free to email me at grant@lucidworks.com. Otherwise, I thank you for your time, and please feel free to stay on for more questions.
Thanks, Grant. So like Grant said, we will now begin the Q&A portion of the session. Again, as we mentioned earlier, if we don't have time for your question today, someone from the Lucidworks team will reach out to you. So the first question, Grant, that we have for you is, how much semantic analysis is available out of the box? What tools have you seen used for a full semantic analysis solution?
Wow, that's a great question to start off with. Like when I think about semantic search, obviously you're starting to think about what is the user intent, what is the concepts behind the data, how do we then marry those things together to provide perhaps a higher level insight into it, into the data or into the questions. Solr itself actually does not ship with all that much, but there are some open source projects on top of it that add to it. Us bringing in, I think, our NLP-based tools, like, the ability to do part of speech and named entity and all of those, and some of the graph API stuff that we're working on, as well as some interesting new things around classification of queries that are coming down the pike in Fusion, I think will all make that easier. A lot of people will add third-party layers in that are specifically designed to do semantic search. I often start off with customers with trying to understand what they're trying to accomplish first. I often find that customers want to run before they walk, and so Semantic search can be great if properly deployed, but I would want to at least make sure you've got the good core capabilities working before you go and spend all your time on something that's much harder and much harder to get right because of the ambiguity of language and all of that kind of stuff. So if you're interested in that, I'd be happy to chat at a deeper level, hear about your use cases. Just contact us, and we can set up a time for that.
Next question. Can Fusion output to other tools like Tableau?
What was the output to tools like? What?
Sorry, Tableau.
Tableau. Yeah, and so in fact, we actually have and have been working on the Tableau connector. We've got, I think, 1 or 2 customers using it. At the end of the day, we're outputting JSON. We're all REST APIs. I know, for instance, there's a Solr R connector. I'm pretty sure that would be really easy to support to use Fusion. And in fact, I think one of our solutions architects have already done that. So you've got REST, you've got JSON. You can actually, with Solr, output and via the Fusion pipelines, you can output JSON, you can output CSV, you can output XML. So all of these, lend themselves to integrating very easily in with those kinds of systems. The other thing that's really interesting is our pipelines are very pluggable and very flexible. So usually with our pipelines, we're outputting to Solr or reading from Solr, but there's actually nothing about those pipelines that is Solr specific other than, a few stages, are about Solr. But so you can output to different systems just simply by either scripting that in or by adding in your own stage. And if you need help with that, that's something that we help customers with as well.
The next question is, could you give a brief overview of the footprint of the infrastructure, i.e. how many servers, etc.?
Yeah, that's a great question. So, one of the things we do is we try to make sure that Fusion is really easy for developers to get up and running. And it's kind of Fusion is a batteries included product. So we do ship with a lot of these capabilities out of the box, like all of the connectors and stuff like that. When you download Fusion, you can literally just do bin Fusion start, and it's up and running on a single node. I believe kind of the developer version, if you want to get data in, you roughly need at least 4 gigabytes of RAM, but every developer these days has probably at least 8, if not 16, and so it's very easy to get up and running on your local machine and doesn't require a lot of footprint. In fact, all of the demo that I've been doing here has just been running on a local machine. If you go back to, let me just go back to my architecture slide here. What we've tried to accomplish here is the ability to scale this up as you see fit. And so all of these boxes can be put on different machines or run as separate processes if you want them to. Now, a lot of users, for instance, will shard out Solr or replicate out Solr and put that across different nodes. They'll do likewise with Spark. And so that's really going to be dependent on either your query volume or your data volume. On the Fusion side, some of the services perhaps require more scaling than others. So pipelines, those kind of scale with the data volume you have because they pretty much align up with how much data is being ingested. And so if you want to scale out data ingestion, you're going to scale out pipelines. Things like the scheduler or, like our low-level system metrics or some of the query processing, those don't necessarily need as many nodes. And so, oftentimes people will co-locate all of those services on one machine or 2 machines in case they want fault tolerance. So, roughly speaking, developer footprint, no problem, 1 node. Kind of a small production footprint is usually somewhere in the 3 to 4 node range. And that's, built-in fault tolerance, failover, and that kind of stuff, or at least for most, fault-tolerant or failover situations. And then really it becomes a question of scaling out. Like we've got customers with Solr who have thousands of nodes, and so they'll have thousands of Solr nodes, but they may not need particularly that many Fusion nodes, obviously. Hopefully that's helpful. Again, it's a great answer if I get to say, just contact us and we can give you specific details and specific insight into your environment and what we think it would take in terms of footprint.
Thank you. So we have time for 2 more questions. The next question is, can you elaborate on the integration with Spark?
Sure. So what we've done with Spark, as I had back on this slide, so Spark just ships as a standalone native service. I'm not a Spark expert, but what I understand around Spark, there's essentially 3 modes that it can run in. One is standalone. One is with HDFS, and I believe the third is with Mesos. I'm sure somebody will correct me if I'm wrong there. So we've chosen the standalone mode for this very first release, the 1.4, but we will then also be supporting, like I said, the support for the other ones, so you'll just be able to point at Spark and say, hey, go call this Spark cluster. Then what we've done is we've built out a Solr RDD for Spark, as well as a few other integrations at a much deeper level. The Solr RDD is actually open source and available on GitHub, and in fact, one of our engineers, Tim Potter, has given talks on it in the past. I believe there's a blog post. So I'm pretty sure that if you just went and searched on the internet for Solr and Spark, you would find our GitHub project, or you would find Tim Potter's talk on that and have a deeper understanding. So we've kind of leveraged that at its core and then made it easy to start and and run. And then like our aggregations, what we've done is we have them such that they run in smaller instances just natively on Solr, and then you literally just add Spark equals true onto your request. And if Spark is running, away it'll go and do its job. And so you manage Spark just like you manage our connectors, or you manage Solr, or you manage the core Fusion API services, or you manage the Fusion user interface.
Okay. So the last question for today, and again, if we didn't get to your question, someone from Lucidworks will contact you. How does Lucidworks automatically do facet, index, and search?
How do we automatically do facet, index, and search? Well, so the faceting side, the indexing side, obviously we just rely on Fusion, or on the pipelines, and then Solr's built-in capabilities around language analysis and all of those kinds of things. So as data flows in through the pipelines, you have the ability to modify all of that stuff before it hits Solr. And you can scale those pipelines independent of Solr, which can be helpful for dealing with large documents or lots of documents. And then Solr itself has, lower level things like language analysis for dealing with different languages or spatial data or whatever it is. And so, we take care, I wouldn't necessarily say it's automatic, but it happens just by simply pushing into the index and doing what you set it up to do. As far as faceting goes, almost all of Solr's, or actually all of Solr's faceting capabilities are at query time, and literally involve just making requests to Solr to facet on certain fields, or facet, do range facets or pivot facets, just like I showed in the demo example here, where I was showing, all of things like the aggregation job or the average word count or any of these. And in fact, if I went in and changed this pipeline, so for instance, I could just go in and update this pipeline, and let's say we didn't want to facet on the user mentions anymore, I could just click and delete that facet and save it, if I can find that, and scroll down here. And now I can do my search. You can see there's user mentions right now, and good Lord willing, live demo. I've removed that from the pipeline, and now it's removed from my display as well. So I'm no longer doing that faceting. And so I guess it's automatic in the sense that, Solr figures it out under the hood, what makes sense in terms of faceting on the values that you've requested. But it's currently not automatic in the sense of, given some query, it automatically figures out what fields it should facet on. Although stay tuned, there's some, I think, new capabilities coming in that realm here pretty soon as well. So I think that's it. As Aaliyah said, we'll be happy to answer your questions offline. I've got some resources up here if anybody has deeper questions. I would encourage you to go download Lucidworks Fusion, just simply go to our website. There's a very obvious download button on there, and you'll be off and running with Fusion in no time.
Yep, so thank you everyone for joining us today. Anyone who registered for today's webinar will receive a link to the recording in the next few days. So we hope you enjoyed today's webinar, and hopefully we'll see you on the next one.